Good evening. This is Saravanan, a physics staff around having experience of 13 years in NEET and JEE. Today just given a demo class about 2 minutes and law of motion. Okay, in NEET and JEE point of view, what are the questions, what are the concepts in the law of motions they are maximum they will ask in exams. The basic concept is about the force. Force, acceleration, mass, momentum, these are the concepts we are going to ask in the law of motion. So, first the application of law of motion, maybe first law, second law, third law, that's long done very well. So, the first class talks about the inertia and second law force of momentum and equal and opposite third law. These are the laws of very well. So, what are the various types of questions they may ask? For we will straight away go to that concept. So, Pully concept. So first I give the application of law of motions in a Pully concept. So Pully concept is a very simple question. So I am going to explain in a very short manner and also elaborate. First, this for example, this is 7 kg. This is 10 kg mass. First, for approach, by seeing this question, by watching this question, immediately we can answer. Some small technique we have to apply. So we need to find acceleration first of all. So acceleration means the law as per force is phi this side, so acceleration in this direction we know very well. And main thing, simply they ask to find the acceleration. Very simple. Acceleration by means of F is equal to ma, law of motion. Acceleration is given by force by mass. So what is the two forces acting on this? There is two forces acting on this. One is 10 kg and 7 kg, but both the masses are in the gravitational pull. So the force is here is 10 kg and here is 7 kg. So 10 minus 7 and this total masses. Add up of total masses 17 and this total setup is in the gravitational pull. So simply we can calculate. So 10 minus 7 into 10, 30 is the acceleration here. It's a very simple way, but the same question they for a NEET they will ask some acceleration, and they ask the extension by the means of free body diagram also we can solve. We can get the tension value. So for the free body diagram, for example, how this free body diagram will be drawn, I will explain that. So this acceleration and tension is no problem. 2 m1 m2 by m1 plus m2 into gravitational pull of g. There is a formula to find out the tension here. So in this sense we can find the tension. It's very easy. And now I am going to explain in detailed way by the free body diagram. So this free body diagram, for example, I keep it as is m1 and here is m2. Okay, there is a tension acting upward. So for free body, I am going to draw the free body diagram for this left hand side. So there is a upward forces of tension and downward forces of mg is acting here. That is m1g. So there is two forces acting. One is upward force, one is downward force. So F is equal to ma. What are the forces? Two forces. Which of force is this? Acceleration is upward. About this drawing, acceleration is upward. So this tension force will be maximum. So T minus m1g is equal to m1m. The same time, the free body diagram for this one, for the right hand side, because right hand side acceleration is downward, so m2g is maximum here, m2g. So tension will be lesser only. So m2g minus tension is equal to m2a. So by solving this two, m2 minus m1 into g is equal to m1 plus m2 into a. That means acceleration is equal to simply we can say m2 minus m1 divided by m1 plus m2 into g. So in that way we can very simply we can get the derivation. The same concept, same formula we apply to this. So by simply watching this concept we can get the answer. But this is a regular method by using applying formulas and everything. Okay. Then now apply the acceleration formula in any of this equation. Number 1, number 2, any of this equation we can get this tension formula also. That's all. So this is a simple technique to apply the law of motion and concept of pulley. So that may be in constant motion, constant pulley also there. That's all. So what is constant pulley and normal pulley they may ask. That's all. Okay.